Where we are today is a place called Pinhay Bay. It's just around the headland from Monmouth Beach near Lyme Regis. And we actually have to be quite quick while being here because it can only be accessed when the tide's at its lowest. And it starts coming in quite quickly and we do not want to be cut off and stranded here. Now this part of the Jurassic coast is very special because we can tell a very important story and also see a very important part of the Jurassic coast story. And what that is the white rocks to the right of me behind there as it goes off to the right and fades into the bottom of the cliff there. And those white rocks symbolise the end of the Triassic period. Now the Triassic period ended about 195–200 million years ago, and for the majority of the Triassic in the UK would have been vast deserts. But as the continental crust started stretching out, the continent started to sink in the middle, and that meant that the ocean started coming in. So the Triassic rocks behind me here symbolise a period of time where lagoons started forming in parts of the Triassic deserts. And then it wasn't until the Jurassic period began, which are these dark rocks which then sit on top. And they symbolise the first marine sediments where the ocean fully submerged these desert parts of the Triassic. You can see behind me here we've got those white Triassic rocks and the dark Jurassic rocks that sit on top. And although the colour helps us point out where they are and identify them, the exact cut-off point isn't quite that simple. And that's because of how many layers of rock we are dealing with here. So although what we're looking at here is the end of the Triassic white rocks into the beginning of the Jurassic dark rocks, the first few layers of dark rocks are still going to be Triassic in age, as the exact cut-off point is incredibly difficult to identify. Now, because of that very reason, scientists have come up with a geological marker to help identify where the first layers of rock to the Jurassic begin. And that's a particular species of ammonite that can be found called Silicirrus. Now, Silicirrus ammonites can only be found in the earliest Jurassic rocks in the layers above the Triassic. And it's for that very reason that scientists use Silicirrus as a way of identifying where the beginning of the Jurassic starts here. Now Silicirrus is the earliest ammonite that we know of here at the Jurassic coast, and therefore, because it's the earliest, we know that it is therefore the ancestor of all other ammonites yet to come, and therefore they evolved from Silicirrus. So what we've got here at Pinhay Bay is a fantastic geological story. And a story of environmental change where the vast deserts of the Triassic slowly became submerged by the incoming ocean, allowing animals like ichthyosaurs, plesiosaurs and ammonites to evolve and thrive. And it's these white rocks here that allow us to see where the Triassic ends and the Jurassic begins. But it's that special ammonite, Silicirrus, that really does help us identify where the dawn of the Jurassic begins.